So this is a warp drive. So what we're doing here, see the video playing? Give me a video, Xavier. Here we go. So this is 6 JBODs with the shittiest, slowest flash drives money can buy. Each one of those is maybe 30 megabytes a second. The entire array is over a couple gigabytes. You got 6 drives here. We made this box to do this demonstration because we wouldn't want to do this to really expensive because the fun thing is to break it. So what you're seeing is one video playing across all 144 of those drives in parallel. The thing controlling the file system is the same video card that is running the RAID array here. So it's a P2000 GPU that's a Quadro from NVIDIA that's playing the video, and it's also making this 144 drive 6 JBOD system look like one contiguous array. And why is that a useful trick? So there's one copy of the video, raw, uncompressed video across there, and if this was using software RAID or regular resilient storage, right, you could use a couple drives and that would be okay, but if you lost a third, you'd kind of be in trouble usually, right? If I'd span this into 2 spans, I could lose 4. But if I lost 5, I'd be in trouble, right? If I were, say, at Amplidata or Western Digital, maybe they could lose 6 drives, but 7, they're in real trouble. This particular array, the GPU is working a little bit because it's got to do error correction real time. It's actually doing a SHA-2 cryptographic checksum on every block of data that's stored, solving a system of linear algebra equations when the data disappears to see what the data is recovered, and then checking the checksum cryptographically to prove that the data it made up to replace the missing data is still legitimate. Now we're going to challenge this video card a little bit by giving the array something to work on. So the trick is here, in this particular case, we have 144 drives. Every piece of every frame is on one of these drives, and as the data goes missing, the GPU's got to work a little harder in order to keep up with it. In this particular example, I think we configured this array for 76 parity. Now the irony here is that as the array goes missing drives, you might say, I got to go in and get out of bed to replace those drives, but the array is actually speeding up because it's faster to solve the equations than the storage media it's on. As a consequence, I can actually make the array out of cheap, fallible components. It keeps running at full speed, even as the math and the array speeds up with age. So I can get out of bed, fix this array, or just let it age because I just don't care because the GPU can solve all of that in real time. Now actually, we'll set this one is configured for 76 parity out of 144, which would be silly, of course, but we just do that to show off. So I'm going to turn off this entire JBOD, excuse me. And I don't know how many drives I pulled out. I was having such a good time. So we'll see. When the checksum can't prove that it can solve it, it finally stops. So that means we crossed over 76 failed drives, 95 missing, and that was the end of our storage array. So the interesting thing is that GPU can do that at about 12 gigabytes a second per storage array that you're doing that with. So if you have an enormously fast JBOD or storage device full of NVMe drives, the GPU can keep up with that and do error correction across a bunch of NVMe drives, say at 12 gigabytes a second per bank of NVMe drives, which we're showing over on the Micron booth as well. So this is, the Boston guys have configured an actual array called the Talon server, which is right over there, which is a whole bank of actual enterprise-grade storage drives that this works on using a GPU to give you this kind of speed and resilience. As a consequence, you need a lot less parity because you don't have to break up a large parallel array into lots of RAID banks and waste 2 parity on each drive. You can just allocate parity that's distributed across the whole thing, giving you a lot more efficient storage. Wasn't that fun? Wasn't that worth your time?
It's entertaining. How long does it take you to reset all of these?
I don't know. Other people do that for me.
But yeah, they will. Yeah.